Let's dive right into the most important question. What exactly is Docker? At its core, Docker is a container technology, a tool used to create and manage containers. That's a great starting point. But what does it actually mean? What's a container in the context of software development? And why would we want to use one? A container is essentially a standardized unit of software. In simple terms, it's a package that includes your code along with everything it needs to run, like dependencies, tools, and configurations. For example, imagine you're building a Python application. Python is a popular programming language used for all sorts of applications, from data analysis to web development. If you were to create a container for your Python app using Docker, that container would include not just your Python code, but also the specific version of Python required to run it, along with any libraries or dependencies your app needs. Why does this matter? Let's consider a simple example. Imagine you have a small Python script. It prints hello world. You initially write and test it using Python 2, and let's run it. It works perfectly. Now, you decide to run the same script using Python 3. Invalid syntax. Wait, what happened? It turns out that Python 2 and Python 3 have some key differences, and code written for one version might not work with the other. This highlights how crucial it is to ensure that your application runs with the right version of its dependencies. The key advantage is consistency. A Docker container ensures that the same application with the same code and environment will behave exactly the same way every time, no matter where it's run. There are no surprises because everything the application depends on is packaged together in the container. To better understand this, think about a toolbox. Imagine you're working on a do-it-yourself project, and you gather all the tools, screws, and materials you'll need into one box. Wherever you take that box, your garage, a friend's house, or even outdoors, you'll have everything you need to get the job done. You won't have to worry about whether the location already has the right screwdriver or drill, because it's all included in your toolbox. Similarly, you could lend this toolbox to someone else, and they'd have exactly what they need to complete the same project, without any guesswork or missing pieces. This idea of a portable, self-contained toolbox is the same concept behind containers in software development. Docker is simply the tool we use to create and manage these containers. Now, the term container might sound odd at first. It probably brings to mind something like a shipping container, but that comparison actually works well. Shipping containers are standardized units used to transport goods. You can load different kinds of goods into them, and the contents are self-contained and isolated from other containers. If specific conditions, like refrigeration, are needed, they can be built into the container itself. Because the containers are standardized, they can be loaded onto any truck or ship designed to handle containers, no matter what's inside. Docker containers work the same way. They're self-contained packages of software that include all the dependencies needed to run an application. You can take a Docker container and run it anywhere that supports Docker, and it will perform exactly the same, regardless of the environment. This eliminates the need to install extra tools or dependencies on the system where you want to run your application. Everything it needs is already in the container. That's what containers are all about, and that's what Docker does. It's a tool that simplifies the process of creating and managing containers. While you technically don't need Docker to create containers, it's become the de facto standard because it makes the process so much easier and more efficient. Now that we know what containers are and understand how Docker helps us create them, you might still be wondering, why do we really need containers in software development? The toolbox analogy might have made some sense, and you can see how it applies to software development to some extent. But is it truly that important and useful? The answer is yes. Let's start by asking ourselves a simple question. Why would we want independent, standardized application packages in software development? A great example, and one of the main use cases of Docker, is the common scenario of having different development and production environments. Here's a simple case. Imagine you've created a Python application that requires Python version 3.9 to run successfully. This isn't a hypothetical scenario. Consider Python code that uses the pattern matching feature introduced in version 3.9. You don't need to know Python in detail to follow along here. It's enough to know that this feature doesn't work in older versions of Python. To execute this code successfully, you must have Python 3.9 or later. The problem arises when you take this application and deploy it to a remote machine, such as a server, where it will be hosted for public access. Your local development environment might have Python 3.9 installed, but the server could be running an older version, like Python 3.8 or 3.6, or even 2.7. Suddenly, the code that worked perfectly on your local machine doesn't run on the server. This kind of issue can be frustrating and time-consuming to debug. Having the same, by that, I mean exactly the same, development environment as the production environment can save a lot of headaches. Docker and containers solve this problem by allowing you to lock in a specific Python version inside the container. This ensures that your code always runs with the exact version it requires, eliminating the risk of version mismatches. That's one example. Another common use case is working in a team or company where developers have different environments. Imagine we're both working on the same Python project. You haven't updated Python on your machine in a while and are still using version 3.8, while I've already upgraded to version 3.9. I write code that uses pattern matching, a feature exclusive to Python 3.9, and share it with you. When you try to run the code, it fails on your system. Of course, you could update Python on your machine to match my version, but that's just one example. In larger projects with more complex dependencies, managing and aligning environments can become a real challenge. It's also inconvenient when we can't collaborate smoothly on the same codebase and have confidence that it will always work as expected in the same environment. Reproducibility in software development is crucial, and Docker makes this possible by providing a locked-in environment with everything the code needs. Finally, even if you're working solo, Docker and containers can still be incredibly useful. If you're juggling multiple projects, you might encounter clashing versions of dependencies. For instance, one project might require Python 2.7 for legacy reasons, while another uses Python 3.9. Every time you switch between projects, you'd need to uninstall one version and reinstall the other, which is tedious and error-prone. With Docker, you can avoid all of that hassle. Each project gets its own container with its specific Python version and dependencies. Switching between projects becomes as simple as launching the appropriate container. No need to mess with your global environment or reinstall anything. In short, Docker simplifies your workflow, ensures consistency, and eliminates the pain of managing clashing versions or mismatched environments. Throughout this course, you'll learn how to solve these challenges using Docker and containers, making them an indispensable tool in software development.